Hello dear students, today is the fourth lecture of coordinate geometry. So far we have learned few things in coordinate geometry for O levels. In the first lesson we learned about the gradient of a straight line. The formula for gradient was y2 minus y1 over x2 minus x1. In the second lesson we learned about finding the equation of a straight line using two different forms. First one was gradient intercept form, which was y is equal to m into x mx plus c, where m is the gradient and c is the y-intercept. Second form was point gradient or gradient point form, in which we use gradient and point x1 y1 of a line to form the equation. Third lesson covered the concept of finding midpoint of two given points. Formula for midpoint was x1 plus x2 over 2 and y1 plus y2 over 2. In the same lesson, we also learned the formula for finding distance between two lines. Square root of x1 minus x2 or x2 minus x1 square plus y1 minus y2 or y2 minus y1 square. This is the fourth lesson, and in this lesson we will learn about the relationship between slopes or gradients of two parallel and two perpendicular lines. If two lines are parallel, suppose there are two lines in the plane L and M, or L1 and L2, gradient of L1 is M1 and gradient of L2 is M2, then gradient of two lines are equal. And similarly, if two lines in the plane are perpendicular to each other, for example, this is line L1 and this is L2 and they are perpendicular, then product of their gradient will be minus 1. For example, if gradient of this line is 2, then gradient of this line will be minus 1 over 2, so that their product is minus 1. Gradient of two parallel lines are always equal, and gradient of two perpendicular lines are negative reciprocals of each other, or their product is minus 1. Let us apply these two concepts in solving different questions. See this question first. Write down the equation of a line which is parallel to this line, y is equal to 3x plus 2. If we compare the given line 3x plus 2 with the standard form of equation mx plus c, then gradient of the given line is 3 and the required line is parallel to this line, so gradient of required line will also be 3. Now that we know the gradient of the line, its equation will be of the form y is equal to 3x plus c, where c is unknown. As we know that there are infinitely many lines which are parallel to this given line, so this c can take up any value, 1, minus 1, 2, minus 2. Some of these equations can be written as 3x minus 1, y is equal to 3x plus 1, y is equal to 3x minus 2, or y is equal to 3x plus 2, etc. So there are different lines. This c is not known. In this question, we use the concept that if two lines are parallel, their gradients are equal. Let us go to next question. We need to find equation of a line which is parallel to this line. Gradient can be found by the same way, by comparing it with the standard form. Gradient of this line is 1 over 2. So gradient of required line is also 1 over 2. Required line passes through the point 0, 2, where x1 is 0 and y1 is 2. So we can use both this point 0, 2 is very important. 0, 2 means this point lies on y-axis. 0, 2 is somewhere like this, x0, y2. So this 2 is basically the y-intercept of the line. Its equation can be given as y is equal to 1 over 2x plus c. C is 2. So this was the question. So required equation is y is equal to 1 over 2x plus 2. Now we move to our next question. Write down the equation of line perpendicular to this line. The lines which are perpendicular to this given line, they are infinitely many. Gradient of the given line is three from this equation. Y is equal to mx plus c. Required line is perpendicular to this line. So gradient of required line will be minus negative reciprocal of 3, which is minus 1 over 3. Hence its equation will be y is equal to minus 1 over 3x plus c. Similarly, c is unknown as was in the previous question. Now we move to this equation. Find this question. Find the equation of line which is perpendicular to this line and it passes through 0, 7. From this, gradient of the given line is 1 by 2. Required line is perpendicular to this line. So gradient of required line will be its negative reciprocal, which is minus 2. And it passes through the point. If one point is given, it is 0, 7, which tells us that y-intercept of the line is 7. So its equation is y is equal to minus 2x plus 7. In this question, we found equation of a line which is perpendicular to this line and passes through this line, this point. Now we see another question. This is last question of today's lecture. Line A passes through point 2, 1 and 5, 10. Let me draw a rough sketch. This is 2, 1 and this is 5, 10. Line A passes through these 2 points. Its equation is, we need to form equation of a line which is parallel to this line and passes through 2, 5. This is point 2, 5. A line which passes through this point 2, 5 and is parallel to this line A. We can find the gradient of A using 2 points. y2 minus y1 over x2 minus x1. 10 minus 1 over 5 minus 2, which is 9 over 3, which is 3. Gradient of A is 3 and required line is parallel to this. So gradient of that line will also be 3 and that line passes through 2, 5 point. This point does not give us the y-intercept. So we will use this form y minus y1 is equal to m into x minus x1. Y minus y1. What is y1 over here? Y1 is this 5. M gradient 3 into x minus x1. X1 is 2. This will reduce to y is equal to 3x minus 1. So this is equation of a required line. Dear student, that was all for today's lesson. We have gone through some questions in which we learned the concepts. that if two lines are parallel, their gradients will be same, and if they are perpendicular, the product of their gradient will be -1. That was all for coordinate geometry concepts. In the next lesson, which will be uploaded tomorrow, we will solve 10 to 15 past year questions from the exam regarding this topic, in which we will apply all the concepts which we have learned up to so far. Thanks for watching. Please share and like and subscribe this channel so that the videos uploaded are notified to you as soon as they are uploaded. Thank you for watching.